Figure out since the time I was gone what goes in 192 evenly. If I divide it by 3, what do I get? I get 64. Hey, there we go. So this would be I times the square root of 64 times 3. And then we can say I root 64 times root 3. The square root of 64 is 8, and then the I, and then the square root of 3. That would be my final setup. We want to remember to make sure when we do take the square root of a perfect square, we stick it in front of the letter I. That's how we need to make sure. So as we type in, fill in the blanks, it's got to be in that order there, is what you got to type in. So now they ask us to kind of solve the equation, so we'll kind of solve each of these just to kind of go through the process. I'll go 7, 9. I'll go down the thing here since we got a little bit of an interruption there. So I stick over the 81. And I get x squared equals negative 81. Remember, I moved it by an inverse operation. Now I take the square root of both sides. Remember, with the x involved in the problem now, that means when I take the square root of both sides, I have to put a plus or minus symbol there. The square root and the square cancel, and I get x is equal to plus or minus the square root of negative 81, and then now I simplify. X equals square root of 81 is 9, and we know we can bring out the negative for it, and we can replace it with an I. Again, just going to speed it up a little bit on this, showing the work step there. Number 9. Move the 15. I can't take the square root until I get that 4 off the x, but I would take care of the 15 first. This gives me 4x squared equals to negative 24. So now divide both sides by 4. I get x squared equals negative 6. Take the square root of both sides. Make sure we put the plus or minus symbol. The square and square root cancel. I get x equals plus or minus. The only thing I can bring out is actually the I. The 6 doesn't have a perfect square factor, so it stays inside. And that would be my simplified version. I have a positive complex or imaginary root I root 6, and then I have a negative version of it, which would basically mean I have it like on two sides of an axis. On the imaginary axis is what that kind of means, is what it represents. All right. Ooh, here we go. I's, the powers of I. The powers of I. So what do we know I to the first power? Well, first off, that's just I. All right. So it's just I. I squared. Well, technically, that's I times I, which is equal to, in this case, what we can say here, it's the square root of negative 1 squared. And the square and the square root cancel, and my answer is negative 1. This is what ends up happening. I to the third power, well, that's really I squared times I. Because can't I split up like 3 as an exponent as 2 plus 1? Kind of reversing the when I multiply like basis. If I had x times x squared, isn't that just x cubed? Because it's x to the 1 plus 2. So here I can rewrite I to the third power as I squared times I. And the reason why I do that, because I know what I squared is. I know I squared is negative 1. So if I can rewrite this as I squared times I, so then I'd have negative 1 times I, or negative I is what my final answer is. As we look at a rewriting, yes.
So if the I is, wait, so when we were doing it above, like when it was,
when we were simplifying and doing stuff, yeah.
so when we were using the I as the negative.
Square root of negative 1. Up here we were saying when I saw a square root of negative 1, I could replace that with the letter I. Now what we're learning is what we're trying to learn is if we see the letter I in there with an exponent, there's some other things I can do to simplify. I got some other things I can substitute in when I see I to a power. not just I to the first power square root of negative 1. I stayed away from this first one going I to the first equals square root of negative 1. Well, we know that's still I. I stayed away from showing that one because really you're not going to substitute back in that square root of negative 1 in the problem as we're working with the complex numbers. So on I cubed again, we have it I squared times I. We know I squared is negative 1 from the previous line. That is times I. And negative 1 times I is just negative I. So I to the third power in a nutshell simplifies to be negative I every time. Because that's what that's saying. I to the fourth power. Well, I can rewrite that if I want. Well, that's a U. I can rewrite that as I squared times I squared. And I did that because I know that I squared is technically a negative 1. And then what's negative 1 times negative 1? Yeah, it's a positive 1. So I know I to the fourth is equal to positive 1, is what I know. I squared is equal to negative 1. And just I to the first is just I. It's just the basics. So now we look over on the other guys. They said, okay, now let's get fancier. Let's say I to the fifth power. All right, fair enough. Well, I could do that as I to the fourth times I to the first, because 4 plus 1 is 5. And with that being said, we know what I to the fourth is. We said it's positive 1. So this is positive 1 times the letter I. So that means it's just I. I to the fifth just simplifies down to be just I. I to the fifth is just I. I to the sixth I can replace as I to the fourth times I squared. Well, that's a positive 1 times a negative 1. So that's just negative 1. So I to the 6 is equal to a negative 1, is what it simplifies to. I to the 7th, again. Well, if I want to, I can say, well, I can do this as I to the 6th times I, because I know what I to the 6th is. It's negative 1. And we know I is just I. And so I to the 7th is just negative I. So I to the 7 equals negative I. And then last, I to the 8th, well, that's I to the 4 times I to the 4, which is 1 times 1, which is 1. So I to the 8 is just a positive 1. Yo! It has. So then that's the pattern. It repeats. The pattern repeats. So if I put up there I to the 9th, what would it simplify to? It should be just I. If I say, what's I to the 10th? Negative 1. All right? You can't see the pattern when you just do 4. But once we see the other 4, then we see, hey, there's a pattern. And that means I can continue that pattern all the way through no matter what we do. Now the challenge is, as you look at some of the problems down here, number 14 says, what is I to the 62? The last thing you want to do is kind of keep doing this thing out all the time to get down to it. So I'm going to show you a shortcut. Okay? I to the 15th is not bad. So this is what, this kind of brings back the elementary school days, is what it brings back in. We know it repeats, Caden, as you just said, every 4. Okay? So what we're going to do on 14 is we're going to take the exponent, 62, and I'm going to divide it by 4 because I repeat every 4. And I'm going to see how many times does 4 go into 62 evenly, and then if there's a remainder. If it does go in there evenly, then I know that it ends in 0 is what it is, and there's a case there. So with this in mind, 4 goes into 6 one time, 22. And then that goes in there 5 times, which is 20. So then a remainder of 2. So 15 remainder 2. So that 2 tells me this is like I squared, which means that this thing is negative 1. So I to the 62 simplifies to negative 1 is what it simplifies to. The remainder lets me know which I am I nearing. Am I to the first, I to the second, I to the third, or I to the fourth? All right. Now, can you have a remainder of 4 when you're dividing by 4? You can't, can you? So if you don't get a remainder, then that means that you're like I to the 4th power, is what that means. So for example, I to the 16. 4 goes into 16 4 times, a remainder of 0. So this would be I to the 0 power, and we learned that anything to the 0 power is what? 1. Okay? So if the 4 divides into that exponent on the I evenly, your answer is positive 1. Now, some of us don't like doing the long division. We like using the calculator. You know what I mean? So here's another way you can kind of remember it. If you get 0.25 as an answer, then you're I. If you get 0.50, then you're negative 1. If you get 0.75 is what it ends in, then you get negative I. If it comes out to be 0 or 1, or I guess 1 or 0, so it's a whole number, there's no decimal. Basically, there's no decimal. Then I am 1. Depends on how you want to phrase that. Does it divide into it evenly? It's 0.0000. That means I'm going to mirror I to the 4th, which is just 1. Does anybody remember? It's been a minute. It's been a month-ish. The ACT. Do you remember seeing the letter I anywhere on one of those problems and stuff? Did it have a power on there, or was it some of this like maybe with the simplifying that we've done so far? Okay. So typically the I is on there and stuff on the ACT, and so Miss Bernard, myself, Miss Lambert, the Algebra 2 teachers, and a lot of us, we it upsets us the state took that away from a standard because we're like, hey, well, you need it for that test. So now all they're asking us to do here is now that we learn that chart, and you need to memorize that chart so that life goes a lot easier on some of this stuff to speed things up. Now it's a matter of just simplifying. So as I look at number 15, what I would do is I would group the real numbers together and then the i's together. 4 times 7 is 28. Then I have I times I is I squared. We now know that I squared, we can substitute in negative 1 for it. And so my final simplified answer is negative 28. So 4i times 7i simplifies into negative 28 when it's all said and done. Number 16, again, I can take negative 4 times 2 times negative 9, and then I. Negative times a negative is a positive, and then 8 times 9 is 72, and it's I to the 3rd power. And again, we know from our chart up above, I know you don't have it memorized yet, but I to the 3rd is negative I. So I can say now this is 72 times negative I, which is negative 72I. On number 17, can I go ahead and multiply the 2 and the 5 together? Hayden shook his head no. Why can't I? It has that cube on it. So, since 2i is a monomial, I'm allowed to go ahead and distribute that 3 to both exponents. So this is 2 cubed, I cubed, times 5i. So that's 8 times 5, and then I have I to the third times I. So this is 40 I to the fourth. Well, I to the fourth, well, that's just 1. So this is 40 times 1, which is just 40. So the letter I goes away. But we use our exponent properties of, hey, I can distribute it to the exponents in a monomial. And then I can simplify. And then once I get my i's combined properly, then it's like, oh, I can use the chart and just put in a 1 for the I to the fourth. And now we just start doing a lot of variation of simplifying stuff. Then we get into like the two-term stuff. Woo. All right. So on number 18, I would kind of break this down as I square root of 3, I square root of 3, negative 8i, negative 8i. That would be I squared square root of 9. And that would be 64I squared. And then I'm just going to go ahead and take the square root of 9 as 3 times 64. And then it's I squared times I squared. So that would be 192I to the fourth. Now I would substitute 192 times 1, which is 192. I would not substitute in at the I squared stage and put a negative there. I think it's easier to kind of go from the standpoint of, let me combine properly all of my i's and substitute once. Because if you start substituting in spots, we start making goofy mistakes and we start jumbling things up when they don't need to be. To me, it's a lot easier is combine everything I'm allowed to combine properly. Get it to where I is listed there once. Now when I have that exponent on this side, what do I do? I, negative 1, negative I, or 1, but I put it based on what I have. So on this one, they want you to take the I out first. That's kind of how this, there's different ways of thinking about it. Now I'm going to write it as I squared square root of 180. And then if you want to substitute in for the I squared, you can. It's negative 1 there. Square root of 36 times 5. And then the last thing I would do is square root of 36 is 6, so it's negative 6 square root of 5. And that's my final answer there. And now as we go a little bit more, and I need to go a little bit on this thing here, just because of some of the problems I picked have some of these things on there. So that's why I need to make sure I cover this part on that quizzes activity. The standard form of a complex number is A plus BI, where we have the A is the real number. That's the real part. And the BI is the complexed. Now they also give us this format there to remind us. There is a proper way to write it. When you're working with complex numbers, you're supposed to write it in a certain format, just like when you're working with polynomials. I'm supposed to write my letters, and my powers on the letter need to be going down in descending order. Biggest exponent, blah, 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 down to the constant at the end. Same thing goes with complex numbers. There's a set format it needs to be in. Real number first, plus or minus the complex part, the part that has the I on it, okay? When it's all said and done. There's only one correct representation to have it shown as, okay? So when we're doing like adding and subtracting, like the first 4 problems here, we treat the I like the letter x. We treat it just like a variable. Okay? So 1, there's no equal sign. I'm not going to solve for the I. We never solve for I because we know I stands for the square root of negative 1. But so here I say, all right, there's a plus sign between the parentheses. So this is just negative 11 plus 9. And then it's plus 3i plus 2i. So the negative 11 and 9 make negative 2. And then 5i plus 3i plus 2i is 5i. And I am in the correct format. I have the I listed second. Why didn't I make the exponent on the I be a 2? It wasn't multiplication. I was adding this stuff. All right. We only change exponents on a letter is if I'm multiplying like letters. Here I'm adding because they're like terms, so I don't mess with the exponents, and that's what we got to make sure we don't do. We don't make that goofy mistake. Number 3, right below it, distribute that negative inside. 7 minus 2i minus 2 minus 6i. Now I would say 7 minus 2 is 5. Negative 2i minus 6i is a negative 8i. And then do I have my real number part first and the imaginary part second? Typically when we're adding and subtracting, we shouldn't have to do, especially basic ones, we shouldn't have to do any of the substituting in for the I as we do stuff. It's only when we happen to see maybe one of those is an I squared that I would substitute in. But since these are all listed I to the first power, I don't have to worry about doing this substituting. The next phase when I get into the multiplying, that's a different story. Okay, when I get into the multiplying of the stuff, then I have to worry about substituting in. So on the next one here, I'm going to put in here the I chart. Remember the I chart. Okay. So as I distribute the 2i, that would be 2i times 8 minus 2i times 3i. So that would be 16i minus 6i squared. And then we got to substitute in for the I chart. We got to substitute. 16i minus 6 times a negative 1. That becomes 16i plus 6. And then, I got to put it in proper form, 6 plus 16i. Real operation sign followed by the imaginary. There's no limit to the type of problems we can kind of come about doing here. Here we can go through our little FOIL process. So 28 minus 7i plus 4i minus I squared. That gives me 28 minus 3i minus I squared. Now I'm going to substitute. 28 minus 3i minus, put in a negative 1 for the I squared. That's 28 minus 3i plus 1. 28 plus 1 is 29, so this is 29 minus 3i. Again, all we've done now is just just introduced a new topic about this complex number I, and I just get to use all my other math skills I've learned in Algebra 1 and we've learned in this thing, and we get to do the same type of stuff. We just have that I in there. And then when we get everything combined that can be combined, then we substitute it for I if it has a power. If I has a power, I substitute. If I is just to the first power, I don't substitute. Okay, that's what we just got to remember. Okay. Can I distribute that 2 on number 9? Am I allowed to distribute that 2? Is it a monomial being squared? No, it's a binomial. So this one I need to rewrite as 6 minus 2i times 6 minus 2i. Then I FOIL. 36 minus 12i minus 12i plus 4i squared. 36 minus 24i plus 4i squared. Now substitute. 36 minus 24i plus 4 times a negative 1. So that's 36 minus 24i minus 4. And then 36 minus 4 is 32 minus 24i. Go ahead. Okay. Again, it's just, we learned one little thing, and it's just working the same type of stuff. Simplifying where we can. We're remembering that if I see a negative inside of an even root, I put an I out front. Can we take the odd root of a negative? Can I find the cube root of negative 81? Sure. You know, let's break it down to a smaller number. Cube root of 8. Negative 2 times negative 2 is 4 times another negative 2 is negative 8. So cube root of negative 2 or negative 8 is negative 2. Okay, so we're only using this I stuff when I see an even exponent as the index on a square root symbol. That's the only time I use it. If it's an odd index, I don't use it. Questions? Because that's enough to stop.